Hello everyone. For this tutorial video, I'd like to discuss how to find triple integrals, which are integrals of functions of 3 variables rather than 2. A triple integral is denoted with 3 integral symbols, a capital E in subscript beneath the 3 integral symbols, and then function of x, y, z, with respect to a small change in volume. So if we choose to divide our volume into infinitesimally small boxes, we would get these exact limits of integration, and then evaluate the innermost integral, and then the integral after that, and then finally the outermost integral, in that order, although technically the order doesn't matter, because just like a rectangle is the same area regardless of the order you multiply the sides in, a cube or prism has the same volume regardless of the order you arrange the sides in. So if we have this specific function and we want to find the triple integral of it over this specific 3D region, we would first rewrite change in volume as change in z times change in x times change in y, as volume is z times x times y. Plug in the limits of integration given, and then finally compute the integrals as if they were normal single variable integrals. Once we do all 3 integrals, we get 15 as our final answer for the triple integral. Now that we have looked at how to work with triple integrals, we can talk about triple integrals in cylindrical coordinates next, which are very similar to double integrals in polar coordinates, except we have a constant z dimension. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.